Solid Edge ST4 includes synchronous assembly design with part-to-part associativity, allowing you to change relationships from modifying part position or geometry top-down or bottom-up. What we want to do is take a look at how we can import data, whether it's 2D geometry or 3D geometry from other systems. And so what I'm going to do is I'm going to change my display configuration to import data. We're going to take a look at the frame, actually the bottom side of the frame for this IronEagle. So the first thing that we want to do is we're going to come over and we're just going to simply open up a document, and I'm going to change my filter to all documents. And in the working folder you're going to see that we've got this cast DWG file. And what I'm going to do is I'm going to take a look at the options here, and you'll notice that when we get in here I'm going to change my INI file, which sets up some basic defaults that I want to use for this particular demonstration, but more importantly, that kind of shows that users can also customize how they read in documents. Now, when you open up a document and read it, you can also preview that document, and if you want to change the background to white, it's very easy to do that. We also support window manipulations. If you need to zoom in or fit the view or turn on and off layers, you have all of that capability. Basically, this is a translation wizard with 8 steps in it, and it allows you to set up basic defaults here. I'm going to use this metric default, and then as I step through, you'll notice that it allows us to select whether we want to turn on the background and what size sheet we want to read this into if we're reading into a draft document. We can do line type mapping. We can also do color mapping from AutoCAD, also font mapping, and then of course hatch style mapping. So we give you all of the capabilities that you need to read in the data and be able to represent it in its best manner. So when we're done with that, setting that up, we can simply open this file up, and it's going to open up this 2D document into a draft file. Now, we've got this 2D information from AutoCAD. What can we do with it? Well, what I'm going to do initially is I'm just going to turn off some of this information just to kind of turn off some of the clutter. And then what I'd like to do is use this 2D information to create a 3D file. We have a command called create 3D, and what we can do with this is I like to make sure that my options are set correctly. What I like to do then is to simply select the information. So I'm going to select from this top view, and then I'm going to select from the right view, and then finally I'm going to select from this front view. And when I'm done with that, by clicking the finish button, it's going to take this 2D information and basically take it right into a part in our part environment. So this is solid edge part, or synchronous part if you will. Now at that point, what I want to do is I want to create a 3D part file from it. Well, we have all the information that we need, so what I can do is I'm just going to go ahead and use a extrude command, change it to a chain option, so I can just select that outside chain, and immediately you can see that I can project this. So I'm going to go ahead and change my options here to get in point and center, and pick up and create my base feature. Now once that base feature is done, then I can actually come over and begin to grab some of the regions that were created from the geometry. And by pulling out, I can create a protrusion. By going in, I can create a cutout. But by using the space key, I can lock it into either a cutout or a protrusion. And I want it to be a protrusion because I want to come out to this endpoint here using the 2D geometry to help me create this particular model. And you can kind of see how easy it is to just select the geometry. Now what I would need to do is go ahead and create the holes that were intended for bolting this part down. So let me grab that region and the final region. And what we'll do is we'll just run these holes through the model. And then finally we also want to get these last set of holes. I'm just going to fence select them. Again, by pulling them up, it puts because they start with no geometry, they start as a solid, but if I hit the space bar I can make them a hole and then just bring those up through to create the mounting holes that we're looking for. Then when we get the basic part set up, then we might want to add some rounds. So I'm going to actually just go ahead and grab a few of these edges here. And then I'm going to turn off the geometry in the background, so I'm going to hide sketches. Kind of gives us a better idea of what this part looks like. So we got the basic part created. You'll notice also something very important here is when we brought in the 2D geometry with the 2D dimensions, the dimensions were automatically converted to driving PMI dimensions. So I can actually come up and select that 10 millimeter. And if I want to change it, you'll notice I can use a scroll key, or I can key in a specific accurate value. Maybe I want that to be 12 millimeters. Now before we finish, we do have holes here, and it looks like the spread on them is 60 millimeters. What I'm going to do is I want to go back to the assembly where we're going to place this part. I need to make sure that these holes are going to match what we have here. So just by going to the Inspect tab, we can do what we call a smart measure. And it's just going to give us some feedback, and it shows us that that's 57 millimeters. So it kind of tells us that our part is not actually the right size. So we'll switch back to the part file, and because these are driving dimensions, we can easily make a change, whatever we want it to be. And in this case, 57 millimeters is what we're looking for. So with that, I'm going to go ahead and save this file. And I'm just going to go ahead and use the name that's already up there, except change the last number to 7 just to give it a quick name. We're saving it in the working folder. Now I don't actually have to close the file. If I need to come back and make a change, I can. But I'm going to go back to the assembly, and then just by going to the parts library and going to the Open Documents option, it shows me any documents that are open, and there's that file that we just saved. So I'm going to drag that into my file here. And then I just need to place it in my file. So I'm going to start placing assembly relationships. I'm going to align the holes with the shaft, and then I'm going to place a mate relationship to the top of this bar. And then obviously I can grab the hole and align it to a hole in the part, and it's going to lock that part into position, and you can see that it fits as it should. Now another thing that we need to take a look at is we want to make sure that our holes do align, and it actually looks like we've got a little bit of an alignment problem. It looks like our 57 millimeters is correct, but it looks like the hole underneath is not the right spread distance. So how can we fix that? Well, in Solid Edge synchronous design, it's actually quite simple. In fact, to show you this a little bit better, I'm just going to change it to wireframe display, and you can see that the hole in the frame is a little bit wider than the hole in our part. So what we can do is I'm actually going to change to a face select mode, and I'm just simply going to fence select the end of our new part here, and you notice it highlights the faces of that part. Then I can use the steering wheel to put it in the center of the hole, and I'm simply going to move this part and align that hole to the hole in my frame. I can pick up the center point, and you notice that it does adjust as I would expect it to. If we go back to a shaded mode, you'll see that that hole does align perfectly as it should. So again, modifying components, bringing information in from 2D, creating 3D, and then applying it into our assembly becomes very simple with Solid Edge ST4 synchronous design. Now, in Solid Edge, also, there's really no need to have multiple CAD systems that are used by our supply chain. Solid Edge is able to basically import data from most popular systems through direct translators. And we're going to take a look at that right now. I'm simply going to come over and I'm going to do an open. And you'll notice here that we have an inventor file. So what I'm going to do is I'm simply going to open that inventor file. And we'll just use a part template. and it's going to go through the translation process here. Now we can also bring in other files using neutral file exchange format such as IGES or STEP, but in this case we've got a direct translator for the inventor file. Now once it's brought in, it brings that inventor file into Solid Edge, and I'm going to just change the color of it. So we will just pick a different color. In this case, let's go ahead and grab blue. And then I'm going to save the file, and I'm going to leave it that same file name with the INV in front, just to show you that it is the inventor file. Then we can switch and go back to our assembly, and then again, just like we did before, it's still open, so I can grab that inventor file, drag it into my assembly, and I can start placing relationships. Now, the cool thing about placing relationships in Solid Edge is if you get to a point where you place an alignment, but you want this needs to face over here, we have a flip command that allows you to flip that relationship. Another thing I need to do is I need to pick up this bottom small face. We can use what we call quick pick. If we hesitate over a face, it'll allow us to pick different faces, and you'll see I can pick whichever one I want. I want that top face, and I want to align it to the top face in our part. When that's done, I've got two relationships on there. So what I'm going to do now is just use the drag component option and simply identify the part in the part's edge and just kind of move it over. Now I'm not really concerned about how close it is, because we've got another part that we want to place inside here that transitions from the 4-hole to this 8 octagon shape type mounting face. So once that's in position, that was reading in an inventor file. Let's open up and read in another document. In this case, I'm going to read in a SolidWorks file. Again, we have a direct translator. So if I just pick the template, in this case, again, a metric part template, it reads that SolidWorks file in very quickly. So again, I'm going to change so that the color is all the same on this part. We'll just come up and pick green. And we'll save the document, again using the default name with the SW in the front of it. And then, of course, we can go and just simply go to our parts library. Now, instead of open documents, actually, I just closed the file. So what I'm going to do is I'm actually just going to go to the IronEagle working folder where that document resides. And there it is. And we can drag that document into our folder. Again, very easily working with foreign data, just bringing it in and converting it to a Solid Edge file. And what I can do is go ahead and create some relationships and put this in its correct position, and it locks it into position. Now, one of the other things that's kind of neat with working with assemblies is you'll notice that a lot of this frame is in this 0002 assembly. But these new files that we just brought in, I left them at the top level, and I really need to translate them into the sub-assembly. So what I'm going to do is I'm going to use my Shift key and select these 3 files. And then under the Modify, I can use the Transfer option, which will take those 3 documents and allow me to transfer them, in this case, into that sub-assembly. So once that's done, I can open up the sub-assembly, and you'll notice when I scroll to the bottom of that sub-assembly, all of those parts, there are those 3 parts that we just brought in. There's the 2D to 3D, there's the inventor file, and there's a SolidWorks file. Again, very easy to work with assemblies. We have a lot of tools in the assembly environment to allow you to get your job done quickly. Now, another problem that we have is this SolidWorks file mounts to our 2D to 3D file very well, but there's no way to mount this to this. So how are we going to handle that? Well, what I'm going to do is I'm actually going to select this SolidWorks file and just simply in place activate into it. Now it is a Solid Edge synchronous file. We brought it in, we translated it into the part environment, and what I'm going to do is turn on the background components, and just by simply using the protrusion command, or the extrude command, I can pick that face off of the inventor file and accept it, and you'll notice that it allows me to come in and actually pick up the face on the SolidWorks file and immediately creates a protrusion. And then it'll also add the dimension. So if I want to change that dimension, I can change this to maybe a value of 10. And you can see very quickly how I can take the face from the SolidWorks file and include a face from the Inventor file and work with these files just as if they were original Solid Edge synchronous part files. Again, very, very easy to work with. Now that you can see that we've got our files in place, I want to make one more change. I actually want to be able to create some relationships between these files. So what I'm going to do is I'm going to come up and I'm going to use an option we call Create Interpart Relationships. And all I have to do is just select the file and then select the file I want to create the relationships with. It automatically picks up cylindrical, concentric, planar relationships. So I can say, yeah, go ahead and save that information. And then you'll notice if I go to a face select and actually pick this face, when I move this face up, let's say I move it up 10 millimeters, notice the green part will respond because of those concentric relationships that were just created and automatically place that file or adjust that file to the proper relationships. Now once we're done with this, you can see that there's a lot of power in Solid Edge ST4 Synchronous by using direct translators and bringing 2D to 3D. One other final thing that I think is really neat in ST4 is the ability now to do a save as a 3D PDF. And so what I'm going to do is I'm just going to give it a name. We'll keep it in the working folder and we'll give it this 01 PDF name, and I'll just simply save it. Then I'm going to go to that PDF location. There's our new PDF, and so I'll simply open that up. And we can now view 3D information from Solid Edge in PDF format. And in fact, because this is an assembly, we can also look at the assembly tree. And we can turn on and off parts. We have the capability to just, check mark. It'll turn parts on and off depending on what we want to do here. If I go to the bottom, there's our Inventor file. There's our SolidWorks file, so you notice I can turn those on and off very easily. So you have window manipulation, you can turn parts on and off, and you can view your information in the 3D PDF file. Very, very powerful in ST4. So with an integrated design environment, Solid Edge ST4 fulfills the vision of synchronous technology for accelerated design, faster, more flexible change, and more reuse with imported data. Thank you.